Hey, this is Sanyam Bhutani and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of the Chai Time Data Science Show. In this episode, I interview Jason Antic, the creator and researcher at DeOldify. This is the second time I am lucky enough to be interviewing Jason. So if you haven't read my previous blog interview with him, please do check it out in the description of this podcast. This interview is really a continuation of that. So I highly recommend that you give it a few minutes. That will definitely be worth of your time. In this interview, we talk all about Jason's software engineering experience. Yes, software experience applied to deep learning. His journey with DeOldify, how he came up with the idea of DeOldify and how he kept on improving it. We talk also, broadly speaking, a lot about software engineering practices and how those were helpful to Jason while working on DeOldify, Fast.ai, and even the top-down way of learning. We talk a lot about that as well in this interview. We also talk a lot about Jason's attitude, which I believe led him to inventing DeOldify, if I may, of there is always a solution to every problem. You just need to put in the efforts to be able to find it sooner or later. For now, here's my conversation with Jason all about DeOldify, software engineering, and the top-down way of learning. With a quick note to the listeners, if you're watching this video on YouTube, please remember to enable the subtitles. These aren't the auto-generated subtitles. I have manually fixed and uploaded them. So I hope that improves your watching experience. The blog version of this interview will be published later. So if you're excited about that, you can find the link to the website where it will be published in the description of this podcast. For now, here's the conversation. Please enjoy the show.
Cool.
Hi everyone, I have Jason on the show, actually on the series for the second time. Jason, thank you so much for joining me on the interview series again.
Yeah, thank you. My pleasure.
It's again a great honor to have you on the show. For the audience that might have been living in an alternate reality, I'd recommend that you check out the previous interview. And for the lazy people who didn't go check that link in the description, could you please give a 50-foot overview of what DeOldify is?
Oh, yeah, sure. So DeOldify was this project I started last year, about 1.5 years ago, actually, that was basically originally supposed to be just this capstone project for Fast.ai. It was going to be like a few weeks, and I was just going to go ahead with this idea I had randomly in the shower that I could use GANs to make colorization of images.
Was that quite literally a shower thought for you?
Yeah, I mean, it was like, so I have this habit of like, if I have a thought like that I write it down right away. So it's actually like one out of like 15 or 20 different project ideas that I had on the list. And I chose that one specifically because I was like, oh, if I get this to work, it'd be really cool. And I think people would really like it. So that was pretty much it. And it took about like 6 weeks of, so the core idea was right, but it's just like the actually getting it to work was the hard part, of course. Yeah. And it's kind of funny. I was documenting my work on Facebook, posting images to family, and they just thought I was crazy because the images just looked awful. They laughed about it. I mean, like it was actually like picture after picture of these fish that were colored with all these rainbow colors, and it just looked so awful. But then just one day it wound up working, and then I got excited and posted it on GitHub and Reddit, and that's where it went viral.
Yeah. Were there any projects, for context, that were at least similar, even in a percentage, to this when you had this idea?
Yeah, I mean, there was a previous state of the art that had been done back in 2017, I think it was, or 2016. It was, I think it was called colorful colorization or something like that. But yeah, there was a previous one, and it was actually hosted on Algorithmia. I think it still is, the website. And so you would, upload your pictures on there, and it would come back with something colorful, but it wasn't nearly as good as DeOldify is today, honestly. Yeah. But, for the time, it was pretty impressive.
Got it. And I believe it's been around an year and 4 months since DeOldify went public, so to speak. Did you anticipate it getting to this stage, or like there's still some lag in your vision, like it's behind as per your vision?
Okay, well, first of all, when I put it up on GitHub, I really did not expect it to go viral to the degree it did. I mean, the thing that made me realize I was kind of in a whole new role that I wasn't accustomed to was the morning after I put it on Reddit, I saw that Cory Doctorow of Boing Boing put an article up about it, and I was seeing all these people starting to talk about it. I was like, oh crap, it's gone viral. That was just a really weird feeling for me, and I actually got like this sick feeling in my stomach that lasted the entire weekend.
Wow. Okay.
Like, oh my god, yeah, my role has definitely changed. So yeah, the original vision of the project was to create something cool in 6 weeks and move on, right? Yeah. Instead, it's taken over my life, and I've been doing it ever since.
Yeah.
So really, I'd say the vision has been evolving over the past year and a half, and it's just basically once I solve one problem, I just keep on getting more and more ambitious and wanting to make it more and more perfect. That's basically what's driving it. So it's just kind of meandering in a vast forest of unknowns and trying to be perfect.
And I recommend to the audience, go follow Jason on Twitter. He's SCITNAJ, Sitnaj on Twitter. And it's been a surprise for me. Like, you tweet these out every day, and it might become normal eventually on Twitter, but I'm still surprised like how good it has been even since when it came out, and now it's been getting better.
Yeah, no, thanks. Yeah, it has been getting better, even since the last open source release in May. Iteratively, little by little, I just keep on knocking out the different problems. It's like I basically characterize it as finding the next bottleneck.
Yeah. So can we talk about the evolution of the project? Was there any point which was like a huge improvement, any major stages of evolution that you want to point out?
Yeah. So the initial release was the GAN based colorization, which was a pretty big improvement over state of the art previously, chiefly because it was very colorful and it was pretty. But it had a lot of problems. It had a whole bunch of glitches, and you had to you really had to cherry pick. Like 1 out of 100 pictures would actually look maybe decent. And I've been looking at these, lately at the old model. I'm like, oh my god, that looks terrible now. So the next release, in between that and the next release, the big priority in my mind was to work on those glitches and stuff like that. So that relates to the NoGAN work that Jeremy and Sylvan and I worked on for his course. So we worked on that was based on like my DeOldify work. It kind of spawned from there, and basically what Jeremy wanted to do for that course is to introduce GAN work that I had done into lesson 7.
Mm-hmm.
And we were trying to make it, in a Fast.ai sort of flavor, which is that you can train it fairly fast, right? And it's practical.
Yeah.
Because, GANs in particular were using up a lot of hardware.
Yeah.
At that time. And so typically it seemed like they were pretty out of reach for, individual practitioners, I'd say, on their desktop.
Mm-hmm.
And so, I was thinking about Jeremy's ambition here, and I was like, well, if we really want to make this practical, if we can get transfer learning to work, that would make this a lot more practical and easier, and it would train a lot faster, and it might even look better.
Yep.
So that's where NoGAN was hatched, and Jeremy loved the idea. And for the next 2 weeks, and this is 2 weeks prior to his course, we were just and him and I and Sylvan were bouncing these ideas back and forth, working rapid fire. It was really exhilarating, and we wound up making it work. I wouldn't say it looked perfect, but what we presented to the course was pretty cool. From that, I saw the potential of taking the GAN stuff I did and getting a handle on the glitches and the quality.
Right.
Because basically I was seeing that and I'm saying, well, I think it seems like the longer you train with the GAN, the worse these glitches get. So maybe the answer is to avoid GAN training as much as possible.
And this is counterintuitive when you start out, because you would expect the opposite based on what at least you read in books or what you read in these blog posts that are out there.
Yeah. Because up until that point, my thought, and I think this is what most people assumed, was that GANs were the answer, to getting more realistic and higher quality images. But yeah, my thinking with this evolved to GANs are a tool to get there, but they also are a double-edged sword.
Yeah.
I mean, people were recognizing that they were difficult to train and stuff like that, but to, figure out a way to actually make that work for you to get the benefits without the difficulties was a real challenge. And I think most people at the time were trying to tackle that problem from the standpoint of like stability and GAN training, which is still a big challenge. Stuff like that. So I was trying to take it, from another angle, which is, well, how do you use what we have already in a more effective way? I really like thinking about problems in that way.
Yeah. We'll talk more about NoGAN in a bit, but I want to zoom out and focus on another theme, which is learning to learn. Now, in your previous interview, you mentioned that after a few follow-ups with a few online courses, you decided to invest your time into Fast.ai. You took some time off from work. Can you tell us what approaches and methods did you learn and experiment while you were like doing this course by yourself? I remember you took the course online and not in person.
Yeah, online. Okay, so I want to give you a little bit of a background on this because I think this is really probably the most important aspect of it. I was interested in deep learning for many years, like ever since like 2012 when AlexNet took over ImageNet and just blew away the competition. And I knew from that point on, I was like, this is going to be a big deal. Mm-hmm. So, I wanted to get in on that ever since. And I started trying to taking online courses around 2015. And, I tried some of the really reputable courses taught by reputable people. And I just couldn't hack it, So I tell people I rage quit a few times on these for various reasons. I won't go, I'm not going to trash any one course here, but I'll just say that they were not very effective for me.
Not very practical.
Yeah. Yeah, exactly. And a lot of them suffer from the same thing that Fast.ai tends to stand against, which is things like elementitis, where you're learning, all these prerequisites before you get to the actual thing you want to do. For example, so I finally came across Fast.ai a few years ago, the version 1 course.
The first
And
version, original one?
yeah, the first version.
Okay.
And I loved it. And I got quite a ways through, but the only problem I had at that point is that you still needed to take a lot of time with it to really do it right.
Yeah.
So I wound up taking a bunch of vacation days to do it from work,
Mhm.
and after I ran out of those, I was like, okay, this is not sustainable. I need to figure out a better way to do this. So that was my only beef with it. I mean, otherwise I was like, wow, this is so great. I just wish I could spend more time with it.
Yeah.
So that's what I did the following year.
Mhm.
I saved up a bit of money, and then negotiated a part-time hours at work, and then really sunk in a lot of time into Fast.ai version 2,
Right.
and did that over the course of 3 months in the summer.
Mhm.
And so, when you asked about learning to learn, that was a huge component of it. Just simply setting aside the proper amount of time to do it.
Yeah.
And to allow for experimentation and, learning the things the right way before you move on.
Right.
I think that's something that it's a little less convenient, but that's really what needs to be done. A lot of times it boils down to that, because
That's right.
yeah. As far as everything else about learning, I mean, that Fast.ai really leads you on that. Like they really have a great philosophy
Mhm.
of, what it means to learn effectively. So that, as they do the top-down approach, where
Yeah.
the very first thing you do day one is a classifier of cats and, well, it used to be a cats and dogs. Now it's like dog breeds,
Dog
isn't it?
breeds. Yeah.
Yeah. So, and that's just really motivating. From personal experience, it's just you're like, wow, and you already feel confident from day one that you could expand upon those ideas and do many, many other things. It's just a great feeling. It's just so different from previous experiences.
Yeah. The thing I feel like, and I've been involved in a few study groups, I feel like all of the fast AI students get confused of how much depth to actually go in, because top down is something we're totally unfamiliar with. So you might see something cool happening on Twitter, then you've just done lecture one, but you want to go off course and start following that. So how do you avoid that, or how do you decide on what to focus on?
Well, okay, so that's a very interesting question, because I feel like that's the real advantage of setting aside a whole bunch of extra time, is
Yeah.
that you can go down those rabbit holes, because I think you should. Honestly, if it's interesting to you, that is probably going to be the best motivator for you to learn, because this stuff's a very broad field. I mean, Fast AI covers a whole big range of what's in deep learning.
Yep.
It's the vision, the tabular, the NLP stuff. And I would contend that, yeah, you probably can't become an expert on everything. It probably pays to know that stuff, to a certain extent, for, I like to term it cross-pollination of ideas, to take ideas from computer vision and apply them to NLP, like transform learning.
Then to GANs.
Yeah. So, but ultimately, you're going to have to pick and find something that you love, and if that happens to be the first thing you see in the course, I'd say go for it. So again, that's why I think setting aside a lot of time for it's very important, to not rush it, but rather explore it.
Yep. I think that answers the project aspect of it. I believe that's how DeOldify start. But what about the other student, half of the students of Fast.ai that want to learn another thing that's not been yet taught in the lecture, that's not covered? how do we like decide how much time to spend on it? Because that leads you to one course from the other, and it becomes an infinite learning loop of courses.
Yeah, I mean, you can go crazy. I mean, like, yeah, if you're totally not disciplined about it, then that can be a problem too, for sure.
Yeah. So did you have any tricks, or like was it a natural flow for you? You didn't get stuck in any rabbit holes there?
No, luckily I didn't. I didn't get stuck in a rabbit hole until I found DeOldify, which I'm okay with. I mean, it's paid off, right?
Yeah, certainly.
Yeah.
Okay, now coming back to DeOldify for a little context again, can you tell what's challenging about DeOldify? You've been continuing on working on it for quite a while. How has the problem not been quote unquote solved yet?
Oh, yeah. I mean, the way I see the problem phrased in papers is they call it an unconstrained problem, meaning that, for example, an article of clothing can be many different colors. And if you think about it, you're not going to be able to train a model, no matter how big and sophisticated it is, to memorize and know every single thing in the world, like what color it's supposed to be, especially like articles of clothing and cars and all that stuff. So
there's no right ground truth.
Yeah. I mean, to a certain extent, there is. Depends on what you're talking about, like grass and the sky and
Skin
and skin and specific types of flowers and stuff like that. So not completely true that it's 100% unconstrained, but it's there's a lot of wiggle room, so it's particularly challenging for a model in terms of like not only is it impossible to get all that data, but also to get a model that will still confidently choose one or the other, not like give you brown for everything because it's average, which is what was one of the major problems I had to tackle with this stuff is, the tendency would be to cheat. And just say, okay, well, I give up. Everything's brown or gray. That's basically what a neural network will do if you're not careful.
Right.
Yeah.
Now, can you tell us how did you find ideas for improving? Like once the first version, which was relatively stable, how did you find ideas to improve? Did you go through research papers? Because I remember you mentioned that you're not very good with math heavy papers.
Oh yeah, I just talked about that yesterday. So yeah, what I was saying yesterday in that Twitter thread was
tweet thread. Yeah, I'll have that linked in the
that's funny. So basically what I was saying there is that I'm not particularly gifted with math. It's a struggle. Like I can read this stuff. And I don't want to be. I don't want to give the wrong impression. I was a math minor. I took the courses like linear algebra and all the calculus courses that you could take. But I kind of more survived the courses than actually really truly understood a lot of it. So you remember a whole bunch for the test and then you forget it. That sort of thing.
Yeah.
As opposed to the coding stuff. The coding stuff was like, a lot more intuitive than me. So still to this day, it's just, I think of the math and papers as like a bad programming language. It's really hard to read.
Yeah.
And I just had to, read it under my breath, one character at a time, and then go back again and again. And hopefully, my hope is that I get at least some intuitive sense of what's going on there, and then I can run with that little intuitive building block in my head, and then play with it from there. You know. So that's basically how I approach papers. Is I really hope that they have the code. Because that's really what I want.
Yeah.
I try to get the core idea of what they're doing, and then I try to simplify it from there. That's one of the first things I try to do. And I've had a lot of luck with that.
For approaching research papers, do you just go through the equations real quick and approach the code and try to cherry pick ideas from there?
Yeah, cherry pick. Yeah, I think that's a good way to put it. I do think a lot of times initial efforts tend to overcomplicate. So I don't try to read too much into what a particular paper does, even if it is groundbreaking. I'm like, there's probably a way to do this in a simpler way. So I'm trying to get those core concepts from the paper. I'm not necessarily trying to replicate what they're doing. Actually, I never really am. What I'm really trying to do is like, cherry pick and see, is this useful? Is this useful? Is this useful? And then Frankenstein into my own work.
Again, the top-down approach where you take an idea, see if it works, and not really look behind the curtain, but if it works, you try to integrate into.
Yeah. That I feel like that's a much more efficient way to operate, honestly. Like there's a number of reasons why I like that approach better. For one, I think you have to lead by experiment and empirical evidence, because that's your ultimate truth. And that's, if you don't do that, you'll be led astray by clever ideas that don't actually pan out in reality, right? I mean, that happens all the time, honestly. It's really kind of funny if you think about it, like batch norm, right? Batch norm is used all over the place, everywhere, deep learning. When it came out, just like any other deep learning paper, it had a whole bunch of math that looked really impressive, and it laid out why and how it worked, right?
Yeah.
But then you may know, what,
2
2 or 3
later.
years later, yes, there's another paper that came out that said, oh, wait a minute, batch norm works. We know that, but it doesn't work the way you thought it did, right?
Yeah.
Which is kind of funny, right? Like, because you had all this, really impressive looking math spelling out how it worked, but yet the core concept was wrong, right?
Yep.
So that's how I look at this stuff. It's like, I find that to be a particularly striking example, because it's like so many people are looking at the same thing.
Yep.
And using it, right?
That's a great point.
Yeah. So that blew me away, honestly. But I think that happens quite a bit. So I'm not trying to be anti-intellectual here per se, but it's just, I feel like if you get too wrapped up in clever ideas, it can actually be a trap, because you get convinced of the correctness by how impressive the theorem is, or something like that, as opposed to, again, your ultimate truth is, does it work or not?
Yep.
Right.
Yeah. That's so. Again, like going back, you had this decade-long experience of software engineering. Did you find that helpful? Again, while doing Fast.ai and while approaching the project, this question to credit is by Vrinda Prabhu from the AMA section.
Yeah, software engineering, I think, is really helpful for this field, actually, but I have a bit of a different perspective on it, I think. As a software engineer, I viewed software engineering as problem solving distilled, and like complex problem solving distilled. Like if you really want to get good at it, that's what you focus on. Because I think there's a lot of people that want to focus on, like, the syntax of a particular language, or like, what does this framework do or this framework do? And don't get me wrong, that stuff is helpful, right? You can, it is helpful to have that stuff up on the top of your mental stack to be able to be efficient at putting together new things. But, the thing that I think truly distinguishes people that are effective at software development and people who are not are the people that don't bury themselves in the messes that they make. Like, because you can make just about anything way overly complex very quickly.
Yeah.
And the problem with that, it doesn't matter how smart you are. We all have very limited mental capacity. We have very limited short-term memory, for example. Like I think it's like what, 6 to 9 digits or something like that you can remember.
Yeah.
That's why phone numbers are like that length. So we have very severe mental limitations that you have to work with and acknowledge. And if you learn the techniques to work with those limitations effectively, then you can do a lot more than you would otherwise. And that's
the challenge also comes in because making it complex might sound cool on Reddit or in your own hacker circle where you have these nerds, but it probably won't sail outside of that.
Yeah. I mean, you're kind of dead ending yourself with something that is clever, but it doesn't actually turn into something very useful. So that's basically what the job of a software engineer is in my mind. If you really look at it, is conquering mount complexity. And in fact, I helped devise our software engineering test at work, and that's how I designed it. It was that it would try to distinguish who could tackle complexity successfully and who couldn't, as opposed to like FizzBuzz or something like that. The simple tests that really just like my CTO likes to say is testing whether or not you can fog a spoon.
Okay.
He's kind of funny that way. So I think that translates directly to ML, right? And machine learning with these deep learning models, we just keep getting more and more complexity piled on, right? Yeah. And I think it's very easy to get lost in that and to not see the forest for the trees, right? Like to not get the big picture of what you're doing. So introducing that discipline into what I've been doing and just ruthlessly trying to simplify over and over and over again, and taking papers that I read and try to simplify over and over again, and just keep on working that iteration. That has been the thing that I think has been a real advantage for me as a software engineer coming into this field.
That's what I think Jeremy also tries to propagate through, especially the second part of the course where he actually gives you a walkthrough of how they iterate over the code, how do you refactor it constantly.
Yeah.
And
he's a big fan of refactoring. Yeah.
Now, coming to the code base, I went to the code base and I was expecting to have a huge code base since the last time I checked during the previous interview, but I counted the lines. It's close to 1.5 thousand lines, which is not a lot. Could you give us a walkthrough of the code base and how is it so small, even given the amazing results?
Well, I can tell you there's actually some superfluous code in there too that I haven't deleted yet. That's the funny thing. I kind of feel bad about that code because I didn't go through it like I normally do and refactor it ruthlessly. I was kind of sloppy about it because I've been a little too excited to get to the next thing on DeOldify constantly. So I haven't taken the time to slow down, which I do think is a mistake actually. So yeah, I mean the code base is very simple. I mean it's just so first of all it's built on Fast.ai. That's doing a lot of the heavy lifting. Fast.ai and PyTorch. Fast.ai provides a lot of the plumbing to, do all the training and, has the code to read the data and augmentations are a big deal. So Fast.ai provides all that plumbing. That being said, what I added was, I customized their dynamic UNet. So it's a slightly different variation of that. And now keep in mind, I had to remember what I did for that versus what I'm working on now. Okay. it is different. Okay. So I'm going to try to be accurate here. So there's some custom code around the UNet which is the generator and the critic,
Yep.
but it doesn't deviate too much. And then the loss function is the feature loss. I added that. And let's see what else. I added some augmentations to like simulate film grain, with basic Gaussian noise and Poisson noise.
Were you familiar with these mathy terms before you started the project, or did you find them out after working on it?
The math ethos?
The mathy terms, Gaussian noise, etc. Again,
Oh,
the
sorry.
mathy terms.
Oh, yeah. No, I was familiar with that stuff before.
Okay.
Yeah. Actually, that was actually something interesting. Like using Gaussian noise, I wasn't sure about, because I was like, it seems like a very loose approximation to what film noise is and film grain. So I wasn't sure if it was going to work, but it's one of those things that's like you just don't know until you try. And so I experimented with it, and it actually did work pretty well. I just like to say that because like that's a really good example in my mind of like leading by experiment as opposed to getting trapped in over analysis as to why something should or should not work.
I think again, to quote an example, you might get stuck in the loop of going through transformers, for example, if you're working on NLP, and if you have an intuitive idea, that might get buried in case you're again stuck in that loop, for example.
Yeah, right. So I think it's actually a really good discipline in general to kind of assume that you're probably wrong in some way and like assume that you're missing something. Don't get me wrong. I mean, I'm saying what I'm saying is that it's to err is human, basically. And I hope I said that right. And chances are, especially when you're dealing with new things, is that you're going to be missing something big. So that's another reason why I like to lead with experiments, because no matter how clever an idea is or how airtight you think it is, there is the very real possibility this is fleshed out by a ton of evidence out there throughout history that we are going to be wrong.
Yeah.
And again, it's no matter how clever you are. I think it's a very easy mistake to make where you can make like a sort of airtight proof in your head about why something should work, but the key fatal flaw in it is the underlying assumptions behind it.
Yeah.
And those are actually the things that we usually get wrong. Yeah. And again, that's, the underlying assumptions are the things that you find out by actually running it.
That's true. Now, I want to again point out this fact that I'd like to mention quote you as the Edison of GANs, where you failed all of these 1,000+ experiments, I believe. How did you document your approach? For me, like if I fail an experiment, it's just RM, RF, I'm not doing this anymore. I'm done with this. I probably just shut down my computer. How do you not give up?
Well, okay. The way I document it, and I don't recommend this, is I have a file called todo.txt. I have it in Dropbox. That part is good. So at least it's backed up. And so todo.txt was originally my to-do list, but then I just started piling a whole bunch of notes in there about what works and what doesn't. Okay. And it's really long now. And it has like, I don't even know what's in there anymore. I just keep putting it in there. Okay. And so I keep procrastinating and thinking, okay, one day I'm going to actually organize this into something useful. Now, I laugh, but like the thing is that is actually kind of hurting me, because I know I've at least a few times I've repeated an experiment like in some way, like I did actually figure out something already, and then after I run it and I see the same results, I'm like, oh yeah, I already knew that. That's my
Okay.
answer. I'm really sloppy.
Okay.
uh, so a lot of it, I mean, I am writing it down. You have to, but I've been really keeping it in my head, which is bad.
Also, like now it's amazing. DeOldify is amazing. We're all fans of it. But how did you not give up? Like, I don't think of any examples that were as good. So I think you might have questioned if at all it's possible or not. How did you not give up when the experiments were not working at all?
Um, so this is actually where my experience as a software engineer really came in handy. So over the years, and this is something I gradually developed. You know, this is not something that I always had, but I gradually developed this conviction that uh, there's a solution out there waiting to be found, and that problem solving a lot of times really boils down to being a search problem. So, like one of the very first things I tell people, new engineers coming in at work, is that, you know, before you come up with a theory of why something isn't working when you're debugging, for example, narrow down the time and space first. Just do something that's don't even begin worrying about coming up with a theory yet. Collect the evidence first. So that's how I approach a lot of this stuff. Is like, I really do think the solution is out there, and you know, it's not unreasonable to think. I mean, it's like, you know, even before I started to work on this stuff, like, you know, as you mentioned, there were other deep learning models for colorization. They weren't as good,
Yeah.
right? So, you know, the proof of concept was out there. It's like, you know, that's where things were going, right? And GANs were doing awesome stuff outside of that, you know, already. Already at that point, progressive GANs from NVIDIA were out, making really impressive looking faces.
Yeah.
So it wasn't really a big mental leap. You know, the challenge is yeah, fighting giving up. You know, and I would even go as far as to say, fighting self-doubt, you know, like thinking that you aren't smart enough to find it. I think really that's the real thing that you have to fight more than anything else.
Yeah. And I think it's again a learning experience as well. Like you have to keep getting better while for example, solving any problem. So you have to also fight the self-doubt while also improving your skills trying to solve that problem.
Yeah, for sure. It's a lot of learning along the way, and you don't know what you're going to have to learn until you get there.
Yeah.
That's the other thing.
You also got to collaborate with Jeremy and Sylvain
Yeah.
on working on NoGANs. Can you tell us about that research experience and how was the collaboration experience like?
So yeah, to give a little context on that, Jeremy and Sylvan and Rachel were my three heroes in the field. You know, like, so when Jeremy contacted me after I put out my DeOldify work, I was ecstatic. You know, and it was like a dream come true. I mean, it really was. So yeah, he contacted me about wanting to incorporate some of the work in DeOldify somehow into his lesson 7 of part 2, part 1. Sorry. And we were to do that in.
Sorry, for the audience, there's multiple versions of the course and multiple
Oh yeah.
of the library now. So what Jason just referred to is version 1 of the library and version 3 of the course.
Yeah. Sorry. Oh yeah, you're right. I'm so sorry. Yeah, it's confusing. Anyway, yeah. So we were to do this work in like 2 weeks, and it was really crazy ambitious in hindsight because, you know, like what, you know, like I said earlier, like what we were trying to do is make GANs practical for the Fast.ai audience, you know, where they can run it on their desktop and train it in a few hours. and get really cool results on, in this case, super resolution, right? So yeah, that's naturally, that's where I went back to what Jeremy had been teaching this entire time, which is, the virtues of transfer learning. Like that's, almost everything seemed to be improved by that wherever you added that. So that's where I suggested to him, like, I think to make this effort practical, to make it train in a few hours as opposed to a few days, we should try to do transfer learning for GANs.
Yep.
And keep in mind that really wasn't being done at that point for whatever reason. I don't know why. So that's what we tried to create in 2 weeks, and we actually succeeded. And it was really fun. Like I'd never had this experience where just, you're working with someone and you just, and all these ideas are just flying and they just click and just, it just flowed so well. It just, the best way to describe it, it was a wonderful feeling. And it was crazy too. I don't know how many people know this, but the last bit of code that was committed for that notebook that Jeremy used that night for that portion, I committed that partly because I made a really dumb mistake, like 4 hours before he taught the course, which I thought was really funny, but it all worked out in the end.
I do remember the people who were a live audience, we used to have our chat, and I saw your icon in the commit thread and I mentioned, hey, Jason's on the lesson.
Yeah. So you saw it, yeah.
Yeah. Now, could you tell us more about how you collaborated, about the ideas or experiments? How were those discussed, tracked, or worked upon during that duration?
Oh man, honestly, it was such a blur. We basically did what I'm used to doing, which is leading by experiment. Does this work? Does this work? No. One of the things that we wound up doing is going with weight norm instead of spectral norm. But again, that was just experiment after experiment. That's all it boiled down to. It was just, and yeah, I don't know what else to say to that. Sorry.
Yeah. Got it. Now, coming to the video results of again, DeOldify, you were kind enough to share them with me way before it went public, but can you tell us how did DeOldify get better enough to work with continuous images, videos, as we call it?
Yeah, that was a really interesting problem because I think that's one of those things, is one of those problems that people thought was a lot harder than it actually was. I think this is a really good case of where, I don't know, for lack of a better term, thinking outside the box really comes in handy with problem solving, and that you question basic assumptions. And the basic assumption there was that you needed temporal modeling for to do effective videos, right? To get rid of the flicker and stuff like that. Now, granted, DeOldify still has some problems with some flicker to a certain extent, but I would argue it's watchable, right? Like it's a pretty good effect, right? And I'm pretty happy with it. But the key insight there was that, so this guy, Robert Bell from Arizona, randomly contacted me with some, back in January, with some videos he did with the original DeOldify.
Okay.
Where he colorized them frame by frame, and they look really bad. I mean, he was happy with them. He's like, because he saw the potential in them, I think, and I was like, and I did share his excitement with that to a certain extent, but I was like, yeah, it looks pretty bad, like what I expected.
In hindsight, it looks bad now.
Yeah, because it had these glitches, right? Like the glitches that I was very used to, where things get these weird red highlights and stuff. And but when I was looking at it closer, so this is like a really good example actually of like just, paying attention to the evidence, right? And paying attention to the unexpected. So I was looking at what was actually going on a little bit closer and was like, well, the underlying images, if you get rid of the glitches, are actually really stable, right? It's just this mess that I got to clean up. And I'm pretty sure this is coming 100% from the GAN training portion.
Mm-hmm.
And it just turned out a month previously, we had worked on the what became known as NoGAN, right? The GAN pre-training stuff. So I just put 2 and 2 together there, and I was like, yeah, you know what? You could probably get rid of these glitches and make decent video and DeOldify by using this GAN pre-training process. So basically, the idea is you're avoiding GANs as much as possible, and you're getting the benefits without problems. So that's where it came from. So that is the line of thinking that started it. Now, figuring out how to actually make it work took a while longer. But again, it was a matter of paying attention to the evidence and experimenting. And in this case, so I in hindsight, I was kind of doing something a little bit crazy, which is I was doing this GAN training on pretty small batch sizes, because I was running it on a desktop, a very humble, normal desktop with this, NVIDIA
single GPU.
Yeah. So, that introduces additional problems, of course. But I noticed over time that the results I was getting through this training were a little bit crazy, in that sometimes, if you ran it to one point, it was good. And then if you ran it a little bit longer, it was bad. And then if you ran it a little longer, it was good again, like the sine wave, right?
The loss doesn't make sense for a GAN most of the time. So you don't have any early stopping. You can't manually inspect the loss curve, so to speak.
Well, that's what I was seeing. Yeah, that's what was driving me nuts. It's like I can't make heads or tails of this. And, it's very tempting when you see stuff like that to think, this is beyond my understanding. I hope someone else figures this out eventually. But I decided to one day just look at it really closely at fine detail. Like, okay, where exactly is the point where glitches are actually introduced?
Okay.
So I was actually taking the model snapshots at like the nearest like 50th interval or something like that.
Makes sense.
And like very small. And I was doing it early on. Mm-hmm. And I was looking at the images, and lo and behold, there was a specific point where all of a sudden it got way worse. But before that, it was just getting better and better and better. So
that's where it overfit.
Yeah. So that's where I was like, there's something useful here. There's a small window of opportunity where you are getting benefits, and then all of a sudden it just starts accruing all this garbage. Now I didn't have the resources to confirm if, increasing the batch size would mitigate that, and it does.
Okay.
Which makes sense, right? But what I found exciting was that even in this very limited resource regime, you can still find a way to make this stuff work, right?
Makes sense.
So yeah, that's where that came from.
Got it. Do you have any suggestions for people who are looking to improve this? Do you think there are any aspects off the top of your head that can be improved in the near future?
Oh, sure. It's not perfect. So, so as long as it's not perfect, it can be improved. But the lack of perfection specifically, I always want things to be more colorful. I really want to get away from everything being blue and pink and purple, right? Yeah. And red. I mean, I've gotten away from that to a certain extent. I'm really happy with the latest results I have with this new model I'm working on, but it's still there. So that I think that's going to be a challenge for quite a while because, like I said, it's a very unconstrained problem, especially with clothing and stuff. Something that I pretty much, believe it or not, I feel like I've solved is making it reliable in terms of like you don't have to fiddle around with render settings. I call it the render factor for DeOldify, where you'd have to render a different resolution to get the best result. That's something I've been working really hard to make obsolete, and I've actually succeeded in that. I would say that's what's going into the commercial work that I've been doing. Yeah,
got it. I'd also like to just to mention it for the audience. Can you tell us the hardware where you created DeOldify, and has it changed since then?
Same hardware. Yeah, just to be clear, you can train this stuff on a 1080 Ti, and that's generally, even though I actually have 4 GPUs, but I use them to run 4 different experiments generally. So, I like to keep it that way.
But all of this was created on a single GPU. So for anyone who's worried about DGX, for example, they can still do this stuff.
Oh yeah. That's kind of the point of it too. I really like Jeremy's vision of Fast.ai, that you're democratizing deep learning. So I like to keep this stuff, running on a gaming PC level of hardware.
Yeah. Now, for someone who hasn't had their app idea yet, if I may, what advice or any suggestions, if you could maybe share a few from your to-do list?
So it's kind of funny. Okay. So to preface this, like, ideas are definitely cheap, right? Like what I used to say as a software engineer, was that if you have any given problem, chances are that not only has somebody else run into it, but they've also written about it on Stack Overflow. It's a really good heuristic because it saves you a lot of time. And it was never wrong too. It's like, I always found somebody else ran into the same problem. So it's kind of a humbling experience too, because you're like, wow, I cannot come up with anything original here. But that's not, so chances are any idea you have somebody at least thought of. So that's not really what's going to set you apart, right? What's going to set you apart is whether or not you actually pursue that idea doggedly. And, I feel like you're on the right path in terms of like being competitive on an idea. Not if it's novel, right? Novelty is not so important. Like, it's rather if you keep hitting these pain points that you're struggling with, and you eventually succeed, but you have the tenacity to do so. Because then you know that other people will have to run into that same thing.
Yeah.
And there's a very good chance that they're going to give up somewhere along the way. So I've accrued a lot of those over the past year with this stuff. So that's, for that reason, I'm like, we probably have a pretty good competitive advantage with this, this mobile app for some time, even though I know Google's working on this problem too. Like, it's kind of intimidating to think about that, but, at the same time, a lot of these problems are things that can only really be solved by having a dedicated person sit down and just really love it and embrace it and live and breathe the problem for quite a while.
Yeah.
So that's my long-winded way of saying, don't focus on the ideas so much as the execution.
Got it.
Yeah.
I'm sorry, I don't have a real physical gift to hand to you, but I'd like to hand you a virtual Chai Time Data Science Award, because Jeremy mentioned on his interview that DeOldify is his favorite project, and if you'd like to do an acceptance speech for
boy. My acceptance speech is thank you, Jeremy, and thank you, my supporters. Because I do have to say, that's been the coolest part about doing this is the support I've been getting and the people I've been able to talk to and get to know. So yeah, I'm truly thankful for that. I'm not just saying that because I have to do an acceptance speech or something.
Yeah, but I think it's really been great. We get to see a lot of this on Twitter. Again, doing a plug for you, but there's Old Island in Color. I think there's also a few other Twitter handles that are you doing this very extensively.
Yeah, that's been probably the coolest thing I've seen so far. Is Pakistan in color. There's Old Argentina in color. New Zealand.
Wow.
We took America. We're probably going to start putting out stuff for that. It's such a cool concept. John Breslin doing the Ireland one in particular is really executed quite well. I love that guy. He's been great. he's pretty much like the power user of DeOldify. So
this has been an amazing conversation. My last question to you would be: would you have what best advice do you have for anyone just starting their machine learning and software experience?
Wow. Yeah. So I would say for machine learning or software development, if you're trying to get into those, going back to what I said earlier, it's just it takes time, and so you need to set aside time, and if you find something that you're interested in, allow yourself to dig into that. Don't feel guilty about it, right? It's very broad advice, but I would also say that I really am a big believer in how Fast.ai approaches the teaching process. You can take what they do and apply it to a whole bunch of other things in your life, with whether you're learning software development and so on, which is again the top-down approach, where you don't have to build up this huge library up front in your head of prerequisites. It's really funny. I mean, like, people keep saying, oh, you need to know all this linear algebra and calculus and stuff like that, and they just do away with that. They just say, no, algebra, that's it. And it's true. I mean, the only thing you need to know from calculus the only concept you need to sort of get with deep learning in terms of like calculus is like, what a derivative is and what the chain rule is, right? Those are the two really big things, and they're really easy concepts, honestly. I mean, there's something that you don't have to have that huge context of years of calculus to get, I don't think. Right.
Awesome. Now, before we end the interview, I'd like to mention your social handles. We'll have your Twitter linked, and for the audience, if you just search for DeOldify, you'll probably find the repository as well. But any other platforms?
Yeah, there's the Twitter. So my Twitter handle, CITNAJ. We do have a DeOldify one. We just haven't been putting anything on there yet. We just so much work to do.
Yeah.
It's really hard with just two people. We have an Instagram actually. And then I'm sorry, it's under Dana's Instagram. That's where she's been posting stuff. Sorry, this has been also disorganized.
But we'll have that linked in case the audience wants to go check it out.
I'll have to send them to you.
Sure.
Yeah. Okay. Because I don't remember them off the top of my head. So that the GitHub's pretty much it, and my Twitter handle. Those are the two places to go that are actively maintained for this stuff right now. It's going to change fairly soon.
And Jason, thank you so much for doing this interview, and a huge thanks to you for all of your contributions to, if I may, a new field that you've created with GANs.
Oh, thank you. This interview's been a huge pleasure.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.